All right, you had questions 11, 12, 13, 14. So in number 11, it says a car of mass 1,200 kilograms rounds a curve of radius 70 meters. So R is 70 meters. Banked at an angle of 12 degrees. So I'm telling you the theta, so you're not going to have to find it. If the car is traveling 90 kilometers per hour, so 25 meters per second, what force of friction must be required? So you're looking for the FFR. Okay, so we go to the y direction. And so friction is already here because they told us the angle that it's banked at. In the y direction, there is no acceleration. So we have Fny going up, Fg going down, and friction in the y going down. Fny is the adjacent side, so it's going to be cosine. Fg is mg, and friction is the opposite side, so it's going to be sine. Remember I had said that when you were solving for friction, don't substitute in FFR for mu Fn, because you're actually looking for the FFR. So instead, in the y direction, you're always trying to solve for Fn. So leave FFR as it is and take it and the mg over to the other side. So mg plus FFR sine theta, and then divide both sides by cos. So Fn will equal mg plus FFR sine theta divided by cosine. Now go to the x direction. So sum of the forces in the x will equal mv squared over r. So we have Fx plus friction in the x equal to mv squared over r. Fx is that should be Fnx. Fnx is Fn sine theta. Friction in the F is really FFR cos theta, and that's going to be equal to mv squared over r. Again, don't change your FFR to mu Fn, leave it, and where the Fn is in your first term, fill this in. So it'll be bracket mg plus FFR sine theta over cos theta, and then multiplied by that sine theta plus friction times cos theta is equal to mv squared over r. Okay, so we want to solve for friction. Right now there's a friction in this term over here, but there's also one stuck inside the bracket. So next step would be try to get rid of the bracket. I'm trying to make it clear, but I don't know that it's working. Okay, so I'd multiply everything by cos theta to get it off the bottom. So mg plus FFR sine theta still stays in the bracket, and we multiply by cos theta, so it's gone. Plus, then the FFR cos theta becomes FFR cos squared theta, and that'll be equal to mv squared over r times cos theta. Now multiply through by your bracket, and I'm just going to pull it over here. So it becomes mg sine theta plus FFR sine squared theta plus FFR cos squared theta is equal to mv squared over r times cos theta. Take your terms that don't have FFR in it to the other side, pull out an FFR, so you have FFR, my sine term was first, but it doesn't really matter, sine squared theta plus cos squared theta. And on the other side, mv squared over r cos theta minus mg sine theta. And hopefully you recognize as this wonderful trig identity equal to 1. And so then we just have FFR on this side, and on the other side we can fill in our numbers. So our mass for this question was 1,200. kilograms. The speed was 25 meters per second squared. The radius was, I think, 70 meters, yeah. 70 meters times the cos, and they gave us the angle, was 12 degrees, minus 1,200 kilograms, 9.81 meters per second squared, times the sine of 12 degrees. Okay? And assuming that you can punch this in okay, you should get a friction of 8,032.616 newtons. Number 11. Number 12 says, traveling home from St. John, you notice the exit to Fredericton has a circumference of 1.1 kilometers. Circumference of 1.1 kilometers, or 1,100 meters, and that's equal to 2 pi r. So r is going to be 1,100 meters over 2 pi. Okay, most people who mess this question up have used the 1,100 as the r. It is not the r. When you do this math, you get 175.07 meters for the r. Okay, so going back to the question, the speed sign is posted as 70 kilometers per hour. So that's your V1, what you can go around with, assuming that it's perfectly banked for that. And 70 kilometers per hour is 19.4 meters per second. And it wants to know what coefficient would you need to travel if you want to go around at 108 kilometers per hour, which is 30 meters per second. So first step is to find your theta. And so again, when we draw this, we have our Fn y and our Fn x and our Fg. And so without friction, if it's perfectly banked, sum of the forces in the y equals may. So we have Fny minus Fg equals 0. So Fn cos theta equals mg. So Fn equals mg over cos theta. Sum of the forces in the x equals mv squared over r. So Fnx equals mv squared over r. So Fn sine theta equals mv squared over r. Sub this in. So mg sine theta over cos theta equals mv squared over r. The m's cancel. Sine over cos becomes tan. Divide by the g. So tan theta equals v squared over gr. V was 19.4 repeating. Squared. G 9.81 meters per second squared. And the radius 175.07 meters, assuming you didn't use the circumference. And when you do this, you should get a theta of 12.415 degrees. Okay? And now you add friction in. So friction will be here. It'll have an x. It will have a y. So you go to sum of the forces in the y direction. And you should get Fny minus Fg minus friction in the y. And this time you're looking for mu. So this is cos theta minus mg, and this time you are going to write mu Fn, and the y is opposite sine theta. So you have to break it down this time. Take your Fn over to the other side and factor, take your mg over to the other side and factor your Fn out. So I skipped a step there. Divide both sides by the bracket. So mg over cos theta minus mu sine theta. Going to have to finish it on the next one.